Hey guys, how are you? I hope all of you are doing well during this MCO. So in this set of videos, this time around I'm going to explain to you all the answers from your test 1. I hope you are doing well with your test 1. So I think let's get started.
Question number 1. How many atoms of aurum are there in 58.27 grams of aurum? So in order for you to answer this kind of question, you need to know what aurum is. So from the list given to you, if you tried to find aurum, you couldn't find one, but if you look closely, aurum, Au, is actually gold. So from here you can find the atomic mass equivalent to 196.9665. Right, let's look back at the question. So from the question, you were asked to calculate how many atoms of aurum are there in 58.27 grams of aurum. So how are we going to tackle this kind of question? So first and foremost, because you have the mass over here, what you can calculate is the number of mole. As always, the number of mole is equivalent to mass over RMM. So the mass in the question given to you is 58.27 divided by RMM from the list just now. So you have the RMM equivalent to 196.9665. Therefore, the number of mole for aurum is equivalent to 0.2953 mole. Okay, now what else do you need to calculate? The question asks you to calculate how many atoms. If you can still remember from my notes, 1 mole of anything is equivalent to Avogadro number. So where Avogadro number is equivalent to 6.02 times 10 to the power of 23 atom. Therefore, since we have calculated the number of mole equivalent to 2.953 mole of aurum, what you can do is you take this number of mole and then times this Avogadro number. So you will get 6.02 times 10 to the power of 23 times 0.2953. You should get equivalent to altogether 1.7809 times 10 to the power of 23 atom of aurum. Question number 1b. 9.2 gram of sodium is reacted with 8.0 gram of sulfur to produce sodium sulfate. Determine the mass of sodium sulfate produced in this reaction. So if you look at this kind of question, you know that there are two reactants given in the question, and both reactants are given the mass. So what you need to do is to find the number of mole of each reactant. So we are going to do one by one, starting from sodium followed by sulfur. Number of mole for sodium equivalent to mass over RMM. From the question, we can see that the mass of sodium is equivalent to 9.2. So 9.2. What is the RMM for sodium? You can actually find from this list. According to this list, the RMM for sodium is equivalent to 22.98977. So we can take 22.9898. So we write here 22.9898. Therefore, if you calculate this, you should get the number of mole for sodium equivalent to 0.4002. Okay, so the same drill you need to do for sulfur. So the number of mole for sulfur is the same, mass over RMM. So 8.0, and the RMM for sulfur should be equivalent to 32.06. So you should get the number of mole of sulfur equivalent to 0.2495. Okay, next, what do you need to do? Since you know that sodium and sulfur both are the reactant, and in the question, a clue has been given to you that sodium sulfate will be produced. So from here, we can say that Na plus sodium should produce Na2S. So how are you going to balance out this equation? So look at S. In the reactant they have 1, in the product they have 1. It's balanced already. So but sodium in the product you have 2. So definitely you need to put 2 over here. So we consider this as a balanced equation. So from this equation we can say that for 2 mole of sodium, you need 1 mole of sulfur. So since we have 0.4002 mole of sodium, supposedly we should need 1 over 2 times 0.4002. You should get 0.2001 amount of sodium that you need. So if you compare this value with this, definitely you can see that this value is way smaller. So since this value is way smaller, so we can say that the actual limiting reagent is sodium. Right. So since we already know the limiting reagent, so we can calculate the product. From the equation we have done just now, we can say that 2 mole of sodium will produce 1 mole of Na2S. Therefore, according to our calculation of the number of mole for sodium, we only have 0.4002. So same drill, 1 over 2 times 0.4002. So you should get 0.2001 mole of Na2S. So look again at the question. The question asks you to determine the mass of sodium sulfide produced in the reaction. So the mass, we only calculate until mole. How are you going to get the mass from the number of mole? So number of mole equivalent to mass over RMM. So the mass is what you want to calculate. The number of mole is the same value that you have calculated here. So 0.2001, so mass. So let's calculate the RMM for Na2S. So from here, you should look at the sodium here. So 22.9898 times 2 because of Na2 plus sulfur. So for sulfur, you should get 32.06. Okay, so the mass of this thing, after you have calculated this and bring it up here, you should get the mass equivalent to 15.6157 gram of Na2S.